Good morning, children. So, in today's session, we are going to learn about Bohr's atomic theory. So, Niels Bohr was a scientist who was a student of Ernest Rutherford, and in an attempt to overcome the objections of Rutherford's model and to explain the origin of the lines in hydrogen spectrum, Niels Bohr proposed his model of an atom. So before going to Bohr's atomic theory, we should know what Ernest Rutherford, what he has said. So he has said atom will be in this form and plus charge will be at the center of the part and the remaining minus charge will be revolving around this plus charge. So here he was Niels Bohr was a scientist who was extremely interested in the study of an atom, but he is not satisfied with Rutherford's model. So according to the law of physics, when an electron moves towards the nucleus in a circular path, it loses its energy, and when it reaches the nucleus, it collides. So that is the Rutherford's model. See, look at here, it will be like this, and electron will be moving in this direction. So when an electron moves towards the nucleus, this is negatively charged and nucleus is positively charged, isn't it? When an electron moves towards the nucleus in a circular path, it loses its energy. When it is moving, it loses its energy, and when it reaches the nucleus, it going to be collide. So that is why Bohr was not satisfied with Rutherford's model. Niels Bohr was a brilliant scientist who proposed his theory in 1913. So according to him, we are having some postulates. Postulates means some important points. So according to him, when an electron revolves around the nucleus in a circular orbit in which they do not radiate energy. Understand, children? So look at the first postulate. The electron revolves around the nucleus with definite velocity in certain fixed closed circular paths called orbits. So look at here. So this is an atom structure. Center will be a nucleus, and each circular path is having certain amount of energy. Understand? The first level is called ground level and the last level is called higher level. What is said according to the first postulate, the electron revolves around the nucleus with a definite velocity in a certain fixed closed circular path called orbits. So each circular path is called as an orbit or shells or energy levels, and each energy levels is given as name, that is K, L, M and shells. Understand, children? It can be given as K, L, M, and another circle will be N shell and so on. So K shell is nothing but 1, L shell will be 2, M shell will be 3 and N will be 4. Understand, children? So what is the first postulate? The electron revolves around the nucleus in a with a definite velocity in a certain fixed closed circular path called orbits. These are called orbits or shells or energy levels, which are given a particular names, that is K, L, M and shells, and K shell is nothing but 1, first shell, and L shell is 2, M shell is 3, N shell is 4. The starting shell will be ground level and the last shell will be the higher level. What is the next postulate then? So look at here. The electron can revolve only in those orbits whose angular momentum is an integral multiplier of the factor h by 2 pi. So this is Bohr's quantum condition for angular momentum. What is said? So here see. This is an atom from center to outermost orbit, or from center to the first orbit. What is the distance? This is nothing but radius. And here the electron who is having mass m, and it is revolving around the nucleus in a circular orbit with an velocity v, isn't it? Yes. So with an angular momentum which is an integral multiplier of the factor, that is h by 2 pi. This is called Bohr's quantum condition for angular momentum. So what formula we are going to get, children? mvr equal to n h by 2 pi. What do you mean by m? M is nothing but mass of an electron, v is the velocity of an electron, r will be the radius of the orbit, and n, if it is first orbit 1, if it is second orbit 2, if it is third 3, if it is 4, 4. So it will be increased. Basing on this orbits, we are going to give the number 1, 2, 3 and so on. So these are nothing but principal quantum numbers. Each shell is having a particular name and particular number, KLMN shells and 1, 2, 3, 4, where n equal to 1, 2, 3, 4. This is called principal quantum number. So this is the second postulate. And third one, as long as an electron is revolving in an orbit, it neither lose nor gain energy. Hence, these orbits are called stationary states or shells. Stationary orbits or shells. Understand, children? So, what is the point according to Niels Bohr? So, according to him, when an electron revolves around the nucleus in a circular orbit, in which they do not when an electron revolves around the nucleus in a circular orbit in which they do not radiate energy. That means when an electron is closer to the nucleus, it is attracted by the nucleus. To remove an electron from this orbit which is closer to the nucleus, it requires higher energy, isn't it? Yes. So as long as an electron is revolving in an orbit, it neither loses energy or gains energy. Hence these orbits are called stationary orbits or shells. Stationary orbits or shells. So they will be having a constant energy and a constant radius from here to here, from center of the nucleus to here, one radius. From here to here, the radius will be increased. From here to here, the radius will be increased. So when it is moving, okay, they do not come closer to the nucleus. They are having particular distance. So when they come closer or when they attract each other, then they will be in collapse. But here there is no collapse. That is, they do not come towards the nucleus, isn't it? So what according to the Bohr, when it is moving in a circular orbit, it neither loses energy nor gains energy. It will be stable. That is why these orbits are called stationary orbits or stationary shells. Understand, children? Next comes to fourth one. The electron in an orbit does not change unless an energy is added or removed. So whatever electron is moving in an orbit, if you add energy, if you remove energy, then only there will be a change. Understand? So if you add energy, what happens? If you add energy to this electron, what happens? The electron jumps from lower orbit to the higher orbit. From here to here it will jump. If you add energy, the energy will be more, which is taken by this electron. Then this electron will be moved to the higher orbit. Next, if it loses its energy, what happens? Okay, if it loses the energy, the electron jumps from higher orbit to the lower end orbit. Okay, lower orbit. So if the electron is present here, it radiates all the energy. Then what happens? As it loses its energy, and again it comes back to its original position. That is its fourth postulate. The electron in an orbit does not change unless energy is added or removed. So the electron in an orbit does not change, means it will not show any change unless if you add energy or remove energy. If you add energy, the electron will jump from lower orbit to higher orbit. If you remove energy, the electron will be moved back from higher orbit to the lower orbit. So here the amount of energy emitted or absorbed in a transition is equal to the difference between the energies of the two orbits. For example, first orbit is denoted as E1, second orbit will be denoted as E2. So the difference between these two energies is given with the formula, that is delta E, change in energy, delta E equal to E2 minus E1. Understand? E2 means higher orbit which is having energy, E2 minus E1. That is nothing but delta E equal to E2 minus E1, that equal to h nu. Understand, children? So understand? Then E2 minus E1 equal to delta E, that is equal to h nu. So the energy of the orbit is related to its size. The lowest energy is found in the smallest orbit. Then so here that is denoted as E1. The highest energy is found in the higher orbit or the largest orbit, that is E2. So the change in energy, okay, when an electron moves from lower to level to higher level or higher level to lower, that the change in difference is given as delta E. Delta E means change in energy. So delta E equal to E2 minus E1, that is nothing but H nu. And next, last one. So the centrifugal force of the revolving electron in a stationary orbit is balanced by an electrostatic attraction between the electron and the nucleus. So here, what do you mean by centrifugal force, children? So the force felt by an object moving in a curved path that acts outwardly away from the center of the nucleus. Understand? So whatever force acted on this electron. Understand? So that force felt by an object moving in a curved path. So when it is, the electron will be always revolving around the nucleus. That will be balanced. So the centrifugal force of the revolving electron in a stationary orbit is balanced by a electrostatic attraction between the electron and the nucleus. That is why they are having a particular structure. Understand? That is only the reason they will be having a particular structure, and the difference between this central nucleus to the outer electron, the distance, the radius will be the constant because of these forces. So these are the 5 postulates. And next we are going to see expression for the radius and energy. So radius, how we should calculate the radius of hydrogen atom. So first of all, did you clear about this Bohr's atomic theory, children? So Bohr's, we are having some important points. First point, the electron revolve around the nucleus with a definite velocity in a fixed closed circular path. Each path is called as shells or an orbits, and they are given as a particular name, that is KLMN shells, and they have given number, that is quantum numbers, n equal to 1, where that is K shell, L equal to 2, M equal to 3, N equal to 4. And next one, they will be having angular momentum. Okay, the electron can revolve in only in those orbits whose angular momentum is an integral multiply of the factor h by 2 pi. So according to this, we are going to get the formula mvr equal to n h by 2 pi. So what do you mean by mvr, and I have given. And next, the electron, when it is revolving around the nucleus, it neither loses energy nor gains energy. If loses energy, what happens? The electron will jump from higher orbit to the lower orbit. If it gains energy, what happened? The electron move from lower orbit to the higher orbit. So they will be having a constant energy and radius. Radius means the distance between this nucleus and the electron. Yes, so the change in energy is given as delta E equal to E2 minus E1, and that is nothing but h nu. And fifth one is the centrifugal force of the revolving electron in a stationary orbit is balanced by a strong electrostatic attraction between the electron and the nucleus. Understand, children? So expression for radius and energy we are going to discuss in the next class. Thank you, children.